Right now, 100,000 ships are crossing the world's oceans, carrying 80% of everything you own. Almost all of them run on bunker fuel, the toxic black sludge left over after crude oil is refined. Shipping produces more CO2 than Germany, and 98% of the fleet has changed nothing. Engineers tried batteries first. A battery pack large enough to power a container ship across the Pacific would weigh over 100,000 tons, more than the ship itself. Then hydrogen. Liquid hydrogen must be stored at minus 253 degrees Celsius, colder than outer space. Neither solution works at sea. Bunker fuel, officially called heavy fuel oil, is the thick black residue left after everything useful has been extracted from crude oil. It is so viscous, it must be heated just to flow. It produces sulfur dioxide, nitrogen oxides, and black carbon particulates as well as CO2. The IMO, the United Nations body governing shipping, has set a net zero target for 2050. In October 2025, it voted on binding emissions reduction rules starting in 2028. The EU extended its carbon trading system to shipping in 2024. The financial pressure is now real and growing. Ammonia is the answer nobody expected. Most people know it as a cleaning product or fertilizer, but ammonia, NH3, contains 17.6% hydrogen by mass. It is packaged hydrogen, and critically, it liquefies at minus 33 degrees Celsius, compared to minus 253 for pure hydrogen. The existing ammonia infrastructure is enormous. The world already produces 180 million tons of ammonia every year, mostly for fertilizer. Pipelines, storage terminals, tanker ships, handling equipment. It all already exists at major ports. Shipping does not need to build a new fuel network from scratch. Green ammonia starts with renewable electricity. Solar or wind power drives electrolysis, splitting water into hydrogen and oxygen. Simultaneously, an air separation unit pulls nitrogen from the atmosphere. The hydrogen and nitrogen are then combined in a Haber-Bosch reactor at high temperature and pressure to make ammonia. In a green version of the Haber-Bosch process, renewable hydrogen replaces fossil fuel-derived hydrogen. The output is identical ammonia, but produced with 95 to 98% less carbon. In Western Australia, the Murchison project will use 4 gigawatts of wind and solar to produce 1.2 million tons per year. In early 2025, MAN Energy Solutions ran its 2-stroke marine diesel engine on ammonia at full load, from 25% to 100%, for the first time in history. This is the engine that powers most of the world's large cargo ships. It worked. In April 2025, the port of Rotterdam completed a ship-to-ship transfer of 800 cubic meters of liquid ammonia at minus 33 degrees Celsius in 2.5 hours. The IMO issued interim safety guidelines in February 2025. Japan has already ordered the first dedicated ammonia bunkering vessel for 2027. Here is the problem nobody likes to talk about. Ammonia is acutely toxic. At 300 parts per million in air, it is immediately dangerous to life. At 25 parts per million, it causes eye and respiratory irritation. A fuel leak on a ship at sea with 25 crew members is not a small problem. Engineers have developed a comprehensive safety response. Double-walled fuel pipes contain any leak within the outer pipe. Ammonia sensors trigger emergency shutdown valves within 90 seconds. Water screen scrubbers dissolve leaked ammonia before it reaches crew spaces. Nitrogen purging clears the system before any maintenance work begins. The honest cost comparison is sobering. In early 2025, bunker fuel costs $500 to $600 per ton. The effective cost of green ammonia equivalent is $1,900 to $2,250 per ton, 3 to 4 times higher. Price parity is projected to be possible between 2030 and 2035 if carbon pricing is implemented. 3 technical problems must still be solved. Ammonia burns slowly. so engines need a pilot fuel ignition system. Combustion produces nitrous oxide, a powerful greenhouse gas, requiring catalytic reduction systems. And every crew member on every ammonia-powered ship needs specialist training that does not yet exist at scale. Green ammonia is not a perfect solution. It is the least bad option for an industry that has no good options. The gamble is whether the price will fall fast enough, the safety systems will prove reliable enough, and the world will run out of time fast enough to force the change.